This is the example on slide 69 of our Chapter 19 PowerPoint. The problem states, for the reaction in the previous example, estimate the value of our standard Gibbs free energy of reaction at 125 degrees Celsius. Is the reaction more or less spontaneous at this elevated temperature? That is the value of delta G reaction more negative, more spontaneous, or more positive, less spontaneous? So, in order to complete this problem, we got to make sure we know all the information from our previously solved problem on slide 68. So, in our previous reaction at 25 degrees Celsius, our delta G of reaction was negative 70.9 kilojoules at 25 degrees C. And they want to know, if we increase the temperature to 125 degrees Celsius, is our reaction going to be more spontaneous? So therefore our delta G would be more negative, or is it going to be less spontaneous, meaning that our delta G would be more positive? So the only thing that's changing here, our delta H of reaction and our delta S are going to stay the same. Only thing that's changing is our temperature and our delta G that we're going to solve for. So temperature, I've gone ahead and written it out here. In Kelvin, 125 degrees Celsius plus 273 gives you 398 Kelvin. And we already have our delta H and delta S from the previous reaction. So if we plug this in to the reaction, delta H, negative 98,900 joules minus 398 Kelvin times negative 94 joules per Kelvin. If we add, subtract, multiply all of that, you should get negative 61,500 joules, or if we put it in kilojoules, negative 61.5 kilojoules. So if we compare that to our original delta G, is it more positive or more negative? So negative 61.5 is more positive than negative 70.9. Therefore, the reaction, let me get my highlighter, is more positive, meaning it's less spontaneous. So it's less spontaneous at higher temperatures.